Good day, ladies and gentlemen. Welcome back to our channel, Nambane Academy, the Institute for Maths and Science. Thank you very much for the support you've been giving us. We are currently busy with a series of videos for Physical Science Grade 12. So we are having a couple of number of videos. Kindly check them. Don't forget to subscribe, like us on Facebook, everything. It's Nambane Academy. Because the numbers have been growing, we will really like to thank you for watching our videos. It basically says you're enjoying the content that we are giving out to you. So tell a friend about us, because the idea is to help each and everyone who's in matric, so that they will be able to do well. So now, under the organic reactions, there's a video for that that is out already. It's basically where we explain all the basic concepts of organic reactions, different types of reactions we have. So this video is not going to assist you if you did not watch the first video. It's about 1 hour 30 minutes or so. So kindly watch that one first and then come to this one, because here we are trying to answer exam questions with the tips that we got from the previous video. So this lesson, I think, is going to be very short, maybe plus minus 30 to 35 minutes. So because I tried finding different sets of questions that we can work with, but honestly, the topic seems to be easily understood in most cases. So I'm going to try and answer this one. I don't know where I took this one, but it's one of the previous papers as well. So it says in the flow diagram below, prop 1in is used as a starting compound for the preparation of organic compounds P and T to represent now the chemical reactions. So before we can answer, we have an analogy that we use, that if I was single and seriously searching, that means now I'm starting from saturated to saturated. That reaction must be substitution. Then I went to the United States of America, where I met a beautiful lady called Sue. So remember this analogy. I will forever write it down, because it gives us the general idea of what is it that is going to be assessed. So what does USA mean? It says if I am moving from unsaturated to saturated, that reaction must be addition. Maybe for better clarity, I must just write everything on my clean page here. So it's triple S, single and seriously searching, is for saturated to saturated. That must be substitution reaction. It's USA, then it means now unsaturated to saturated. That reaction must be addition reaction. Then I met a beautiful lady called Sue. Then it means from saturated to unsaturated. That reaction must be elimination reaction. It must be elimination reaction. So this, I'm just writing it down as my reference point, my cheat trick that I am taking now to the exam. But I am going to write it on top of my question paper, such that it's things that I can easily remember. So why do I need this? I just need this because it's going to assist me in terms of knowing exactly what type of a reaction I am answering or looking for. Because once this is being done, it says to me, all my answers are going to come from there. Then remember, for reaction conditions, now we said, because I was single and seriously searching, went to the United States of America and met a beautiful lady called Sue. So because of that, God blessed us now with 4 kids. If you remember, it's C, E, D, S. So it says now for C, it is for concentrated, and then E, it's for elimination, and then D, it's for dilute, but S is for substitution. And then we went to heat. This is just a crash course now quickly. Heat, we said we have mild heat and we have strong heat. And then we said with strong heat, it will probably be for elimination. And then with mild heat, it will be substitution. So with this, I'm going to be able now to answer the questions fully. So let's answer the questions and see. Name the type of reaction represented by P. So where is P? P is starting from propene, which is unsaturated, moving to an alcohol, which is saturated because it contains only single bonds. So definitely P must be addition reaction. If you don't want to say addition, you can further explain what type of addition. I think we'll also accept high hydration. So you'll get a mark for that. Then you further move to name the type of reaction represented by S. Where is S starting? S is starting from an alkane, which is single bonds. So we are looking at this single bonds. But what is our end product? Is it saturated or unsaturated? It's saturated. So we are moving from saturated to saturated. That reaction must be substitution. So the correct answer here must be substitution. If you don't want to say substitution, because we see they added chlorine, so it means it must be also halogenation. I think we can accept that as well, halogenation, or even chlorination for that matter. But what about Q? Now with Q, what is our starting point? Our starting point is an alcohol moving to a double bond. So we are moving from saturated to unsaturated. So saturated to unsaturated, it must be a elimination reaction according now to this analogy that we developed. So I'm going to write there Q must be elimination. And what kind of elimination? If you further want to explain it, I think it will be now, the first one was hydration, so it must be dehydration. What about Q? Q is starting from haloalkane to an alcohol. Haloalkane, saturated. Alcohol also saturated. So that reaction must be substitution reaction. Must be substitution. I don't know what happened to my pen here. It must be now substitution reaction. Substitution reaction. So this assists a lot in terms of us getting the right answers. So already I know that this 4 marks is guaranteed out of the 18 because of the analogy that I have. So now for reaction P, that is now 4.2, formula of a suitable catalyst. Let's look at reaction P. Reaction P is starting from a double bond to an alcohol. So the only catalyst that we are using there is H2SO4, or you can even use H3PO4. Fine. Then the structural formula of the alcohol that is formed. Let me copy this so that I can create space for us, because this one I want to explain in detail as to how are we going to get the product that is going to be formed. So I'm going to explain it. Remember, in the first video I said we have a rule called the Magognikov's rule. So Magognikov's rule, what it basically says is, I'm going to explain it with this particular principle. You will never be asked to define or give or state what the rule basically says. It will forever be an application of the rule. So I'm going to write here, we are at 4.22. So they want us to draw the structural formula of the alcohol. So what is my starting point? My starting point is prop 1E. So I'm going to draw prop 1E. Prop 1E. And then add now H2O. So when I do that, it allows me now to apply the Magognikov's rule. So I'm going to try and explain the Magognikov's rule in simple terms. What Magognikov's rule says is, the carbon with a higher number of hydrogens will receive more hydrogens. So if we have a carbon like this carbon here between the double bonds, this carbon will receive more hydrogens. So it's basically the principle of the richer will get richer. So in the double bond, if I have more of the hydrogens, it means I'm going to receive more of the hydrogens. So the analogy that we can use there is the richer will get richer, because now remember, we have this part here that will form the alcohol, and then we have that hydrogen. So the question is, where will the hydrogen go? So the hydrogen will go to a carbon with a higher number of hydrogens. Then the OH will come now to a carbon with lower number of hydrogens. But our focus area in this case should only be the double bond, the carbon between the double bonds. So the carbon between the double bonds is this carbon here, carbon 1 and carbon 2. So but carbon 1 has how many hydrogens? 2. Carbon 2, how many hydrogens? Only 1. So for us to get the major product, it means we must apply the Magognikov's rule. So hence I did not want to explain the Magognikov's rule earlier in the videos, because the only thing that we need to know is the application of Magognikov. So in such a situation where you have unsymmetrical molecule in terms of the position of the double bond, it means now the OH will go to a carbon with less number of hydrogens. The hydrogen will go to a carbon with a higher number of hydrogens. So the easiest way of you remembering it is saying the richer will get richer, but who is the rich? The rich is the ones that have more hydrogens. Between what? Between the double bond. So it allows me now to draw my final product, which will be an alcohol, 1 2 3 OH, and then the only thing that is left is for me to add hydrogens. Now add hydrogens, add hydrogens. But now remember, the question only wanted now the structural formula of the alcohol that is formed for 2 marks. So basically the answer is it's now here. This part was just an emphasis of you understanding why will my OH sit now at carbon number 2, because now if you did not understand 4.22, it means 4.23 is going to be a challenge for us, is going to be a problem for us. The reason being 4.22 and the IUPAC name of 4.23, they relate now to each other. So if your structure is wrong, automatically you are going to get 4.23 wrong. And now it's 2 marks, 2 marks. So it's a lot of marks that we cannot afford now to lose. And we are here to accelerate your performance and ensure that you definitely do well. So hence we needed to explain first in terms of the Magognikov's rule. So 4.23, it says now give the IUPAC name of the alcohol. So I have drawn the alcohol already. So the alcohol, we can count from here. It's 1 2 3, and then even if you count from right to left, it will be 1 2 3. So it says now my OH, regardless of which direction I'm taking, it will always be in carbon number 2. So the right way of saying it here, it is propane. It's an alcohol, propane as the parent name. The position now of the functional group, that is carbon number 2, and the suffix for the functional group, which is now propane 2-ol. So this will be your 2 marks. So your 2 marks is given for the parent name and now the position of the functional group. So I must also mark this one of a structural formula. You get 1 now for the correct functional group and 1 for the correct whole structure. Ensure that each carbon has a maximum of 4 bonds and you have all your hydrogens, because you get penalized for not having the correct structure. So I believe that is clear. That is the reason why we needed to explain in terms of the Magognikovs at 4.22. Now at 4.3, for reaction R, the type of addition that is occurring at R. So they are telling us at R we have addition at R, and we know that R indeed we have addition. We agree it's addition. Why is it addition? Because it's moving now from unsaturated to saturated. So from double bond to single bond. So it says to me now, write down the type of reaction. But now the only way of me getting only a hydrocarbon, which is an alkane in this case, it means I must add now something like H2 plus, or sorry, I must add hydrogen. So me adding hydrogen it says definitely this should be now hydrogenation. This should be hydrogenation. Remember, it's a type of addition. Now at 4.32, write down a balanced equation using the structural formula. That is very, very important. So we are at 4.32 using the structural formula. We must now drop prop 1 in. As 1, 2, 3, double bond, hydrogen, 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 and I am happy that now all the carbons have a maximum of 4 bonds. What am I adding? I am adding now hydrogen, HH. Remember, they said now structural formulae. Then my product here will be 1, 2, 3, and then what did I add? Hydrogens, and then hydrogen, 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 and another hydrogen. So I will definitely get my 3 marks for doing this, because already I know that the only way of me getting an alkane, it's me adding now a hydrogen gas to this prop 1 in. So now this becomes a product that we get, and then we used now the structural formula. If you use anything other than this, remember the challenges you forfeit marks, and now losing marks is not what we want. Now it becomes easy to answer also 4.4. It says now during a reaction T, the haloalkane reacts in the presence of a base to form an alcohol. IUPAC name of the haloalkane. Let's go back to this analogy of ours. Where are we starting? We are starting from a haloalkane, that is reaction T, moving to an alcohol. So it's saturated to saturated, so it is substitution. And what did we say? We said our alcohol is propan 2-ol. So it means we are going to substitute our alcohol with now a halogen. So if you are going to substitute it with a halogen for the reverse reaction of T, then it definitely says now at T, the chlorine, which is now a reactant in this case, must only be at carbon number 2. So I am going to write the name here as now 2-chloropropane. 2-chloropropane, because now from alkane to haloalkane, it is also another substitution. But now we had to look first at what is our major product of the alcohol, such that now this reaction can be a substitution of haloalkane to give us an alcohol in the presence of a base. So that allows us to fully understand why we needed now to go back and check which reaction is occurring. So name of the suitable base, I think this one is easy. It can be something like sodium hydroxide, hydroxide. Then it's 1 mark. Then here you get 2 marks. Then 4.43, 2 reaction conditions. 2 reaction conditions. I'm going to go back to my analogy again. two reaction conditions. One is I'm going to talk about the base, so it's definitely going to be a dilute strong base, because it is a substitution reaction. We said we are moving from a haloalkane to an alcohol, so it is from saturated to saturated, so that reaction must be substitution. So for substitution, the first thing that I know is, according to this analogy, the first thing must be dilute strong base for substitution. That is now condition number one. Condition number two, in terms of heat, it is going to be mild heat. It's easy because now you have everything in front of you. It is just an issue, a question of where do I start and what is it that I am looking for. So I'm going to write here, one is to have dilute strong base. Then the second one is for us to have now mild heat. You can even have that one of excess water. It will be accepted, but it will be excess water, mild heat, because you cannot use excess water and dilute strong base at the same time. So it will be dilute strong base, or even excess H2O, excess H2O. So it becomes easy once I have my analogy in place, once I have the system that allows me to interpret the questions fully. So it becomes easy once I know what is my starting point and where is my final point, and a way of answering according to what the examiners are asking me. So it looked like an easy question to do, but now it was not that easy, because if I did not have this analogy here, this exam cheat analogy that I'm going to use in my exam for me to remember. Remember that now in an exam, we are studying a lot, there's a lot to remember. So, but this analogy becomes easy to remember. It becomes easy for you to apply when you are given now different questions. So this was just a simple example one of applying the analogies and the exam tips. So I'm going to go to another question with the same approach of using the analogies that we have. Let's start now with 4.14. It's a different question. 4.1.1. Let's read the stem of the question. The flow diagram below shows the conversion of propane to propane 2-ol. So we are starting with propane, which is saturated, and there's a step in between here of X. So that step of X we'll see, but we are also going to move from X to propane 2-ol, which in this case we'll say it's saturated as well. So with this, it becomes easy for me to see that if I'm starting with, according to the analogy, if I am starting with saturated, let me best maybe copy this. Let's copy this. Let's copy this. Okay, it's fine. Let's go to the question again. Once I know, I'm just going to write it in simple terms here so that we get it closer to us. It's SS, USA, and then SU. It will be easy for me to remember. Now, I am starting from saturated, substituting it with now a BR. So it is substitution because it's starting from saturated to saturated. So step 1 must also be substitution reaction. But now if it's substitution reaction, it means X must be saturated. So from X step 2 to propanol, it must be another now substitution. Why substitution? Because I'm going to start from saturated to saturated. So already I'm in a position of understanding the diagram that is given to me, understanding the flow diagram as it is in terms of each step, what is it that is now representing. So because now if I am starting with unsaturated, of which I don't have in this case, so there's no way I can have addition reaction. So if I'm starting from saturated to unsaturated, that will not be possible here, because now if I'm starting from unsaturated, I must eliminate. So I'm starting with 3 and then I'm still remaining with 3. So the only thing that step 1 can be, it must be substitution. First thing that step 2 must be, it must be substitution as well. So let's answer the questions and then see if this will assist us. Now, one other thing is the conditions. The conditions, we said if it's substitution, it must be mild heat. That is very, very important. One condition also must be a dilute strong base. We must remember that. So state 1 reaction condition for step 1. Step 1, it's substitution, so it's easy. We just need to have heat. If not heat, maybe you can also use something like sunlight. Fine. Then 4.12, write down the name or formula of the inorganic compound formed in step 2 or step 1, inorganic. So if they say it's inorganic, it means it must not in simple terms, it must not consist of a carbon. Remember, carbon is what makes our chemistry or our organic chemistry. So the basic thing that they are asking us there is it must not have a carbon. So let's see in terms of explaining it in detail. I'm going to try and draw the structure. It's C, 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 H, 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 for the purpose of fully explaining what is going to happen. Fine. And then what did they add? Br2. So we are going to have something like it's substitution. So 1, 2, 3, and then we substitute Br at carbon number 2. And then now we still have the HBr. They did not ask for the whole step, but it's easy because now this video, remember, it's an explanatory video for you to understand. So in this, you will do it or on your scrap somewhere or your on top of your question paper, such that you are able to see that now the correct answer there should be HBr. So I'm doing this for the purpose of explanation. It actually not allowed for you to write the whole balanced chemical reaction. But now for the purpose of you understanding, the person who's watching this video currently, it's easy for me to explain or show you how we got to the HBr. That is the purpose of this particular videos. So the correct answer there is your HBR. That will be 1 mark as well. So 413, name the type of substitution reaction represented by step 2. So the type of reaction represented by step 2, we are moving from this haloalkane to an alcohol. So it means it's either excess water as a condition or dilute strong base. Then it means it must be hydrolysis. Then it must be hydrolysis. 4.41, name or write down the name or formula of the inorganic reagent needed in step 2. I did say it's substitution, so it's either excess water or dilute strong base. So we can accept either one of the two, but now they want the name of inorganic reagent, so you must write the name. So the name is water, or name or formula, sorry, name or formula. So we can accept water or H2O as one, and then maybe you can just write dilute sodium hydroxide, or you can even give the name there of sodium hydroxide, because that is what they are asking, either the name or the formula. So key thing, it must be dilute. It's a substitution reaction. So this analogy here gives me now the best confidence ever in terms of answering these questions, because I know that it must be dilute from this. So there's no way that they can penalize me for that. And then we are now at 4.15. Write down the IUPAC name of compound X. I have compound X. There it is. This one here, it is compound X. So this one is X. So if this is X, I can give now the correct name for it. So it's going to be easy to do that. It will be 2-bromo propane. One for this section and then one for that section is part marking. So you get your 2 marks. Very easy, because I have done now everything. So it is just an issue of how best do you approach the questions, how best can you sit down and analyze the questions that are given to you. So this sections becomes easy and understandable. I will emphasize only because of this analogy that is here. So take this analogy, apply it to the majority of questions when you practice, because our subject requires us to practice and practice more. So once you do that, then it says you will be able to remember it fully, and at the same time be able to understand the type of questions. So when you check this question, it's just another flow diagram. When you check this question, it's basically another flow diagram, but they are addressing different things, but the analogy still works 100%. So I am interested in the final question, which is now 4.2. That is the reason why I chose this question. When I came across it, I was like, yes, this is now something different, something that has never been assessed regularly or more often. So I'm expecting that the whole of, or the new trends that are coming, it will be this kind of equation here at 4.2. The reason for that is flow diagrams have been assessed for the past so many years. So now the examiners are trying to come up with different ways of assessing organic reactions. So this is a new one. So they are going to check how learners performed on this question, specifically 4.2. If they did not do well, expect to have another type of question such as this one. So let's get into the question. The question says now, ethane can be prepared from chloroethane by a two-step process. You are supplied with the following chemicals. So you have the chemicals there. So the question is, select the chemicals in the above table that can be used for this preparation. Use the condensed structural formula, very key. Write down the balanced equation for each reaction and indicate the reaction conditions for each reaction. So for the whole full now 8 marks. Now one will say, where do I start? At the end of it all, I want to end up with a single bond ethane. So it means somewhere I must create a double bond. So the only way of me creating a double bond, because I am going to start with a haloalkane, it's if I start from saturated, produce or form now a unsaturated organic molecule, then that reaction will be elimination. The reason why I need unsaturated molecule is because if I have that unsaturated molecule, I can add the hydrogen to it or break it down such that I can end up with a saturated molecule. So the first one will not work, you see, because now if I'm starting from saturated and to saturated, I'm still going to be stuck with a saturated and molecule. So I need to have a double bond that is unsaturated, and then I can add hydrogen to it. Then I will be able to form my ethane that is being prepared. So the first step, I'm going to start with CH3, CH2, Cl. That is now the starting step. And we said now we have concentrated sodium hydroxide, concentrated H2SO4, and ethanol. Now let's go back here and check. For elimination, I must use concentrated strong base. Already the analogy is addressing that. So I know that as part of the reactions, I must have now plus concentrated sodium hydroxide. But remember, we said that this sodium hydroxide must be now in ethanol. Must be in ethanol. So I'm going to write it here to say it must be in ethanol. Do we need heat for elimination? Yes, we need heat, strong heat. So I'm going to add here that we must have heat also as part of our reaction condition, because it says here indicate the reaction condition for each. What will be my end products or the products? I am going to have CH2 because I am breaking this here So I'm going to have CH2, CH2, which will be my double bond, plus, remember, I'm going to have also sodium chloride, and then I'm going to have water as well. So this is a critical reaction for elimination, that every time when sodium hydroxide is used or concentrated uh, strong base is used, we are going to have three products: the double bond, H2O, and then your salt that will be formed. So majority of people will forget about these two and only give that. We expect you to give out everything, because we can ask anything that relates now to this particular reaction. So remember, you will always have your double bond plus now your salt and water. So this is basically step one. Let's go now to step 2, because we are told that it is being produced by a two-step process. In the two-step process, I'm going to have CH2, and then add now the hydrogen. So if I add the hydrogen, what is my catalyst? My catalyst is PT, and then it will give me CH3 as well as another CH3. Now, the complex part of the question, or the challenging part, is where do I start? But now we're told we must start with chloroethane. So starting with chloroethane, eliminate in the presence of sodium hydroxide and ethanol through heat, then get your double bond. Once you have your double bond, it becomes easy to add anything to it to produce what you want. Very, very, very important and critical. So the way they mark this will be 1 for sodium hydroxide, 1 for ethanol. Okay, it's 1 for the heat, and then 1 for 1 for CH2, 1 for sodium chloride, and then 1 for H2O, and then you get 1 for adding hydrogen, catalyst PT, and then the final answer. So now this becomes your 8 marks. So it's a different type of question. They can ask it now in terms of structural formula. In this case, they ask it in terms of the condensed structural formula. So go back, check the difference between the two. This will be our structural formula where we show all the bonds. Then this will be our condensed structural formula, because we'll penalize you for not writing as per the request of the examiner. So the examiner was asking for the condensed structural formula. So this question is very nice. That is the reason why I chose it, because it addresses now a new way of asking questions. It addresses a new way of how questions can be asked and how should we be able now to answer. But I will forever say, remember the analogy. Write it somewhere in your question paper that they give you when you are going to write, or when you get to question 4, write it down for you to remember, apply it, and definitely you will be in a position of getting better marks than any other one once you apply the principle and the analogy. So I wouldn't want to emphasize it more, because it will be more practice and more practice, and then when we do our revision work, by the time we get there in this section, believe you me, you will fully understand it, be ready to answer questions, and by so doing you will definitely do well. So it's an analogy that I have, that I'm using in most cases, and it helps me. So if you have something that you know also that can assist, kindly share in the description below or the comments. Then we will be able to take it further and then assist the next person who's going to watch this particular video. So remember, in the description we have a link to our WhatsApp group. There it's where we share our PDFs of these particular sessions. We engage, and we are in the process now of having online classes. That will be very, very nice, because it gives you now a chance and opportunity for you to ask questions. So from me to you, thank you very much and have a lovely day.